and then you can get started whenever.
Okay. All right. Get going here. Whenever you're ready.
Let's do it.
Okay. All right. Good morning and good afternoon, everyone. Thanks for joining. My name is Chirag Dave. I'm a principal database specialist solution architect specializing in Postgres. And along with me, I have my colleague Simon. Simon, would you like to introduce yourself, please?
Hi, everyone. Thanks for joining us today. I'm Simon Comendera, a Principal Database Specialist Solutions Architect for MySQL engines.
All right. So again, thanks for taking time and joining this webinar. And today we're going to talk about Amazon Aurora Serverless V2 essential strategy for adoption. So if you are one of those customer where you're using RDS, MySQL, or Postgres, or you're using Aurora and curious to know more about what Serverless V2 has to offer, is this a new service, is it a feature? And more importantly, if you're looking to adopt this service, uh, what are the essential strategies? And we want to kind of dive into all of that. So looking at the agenda, as I said, first I want to start off with the introduction with Serverless V2. I want to talk about what are its scaling capacity or scaling principle and capacity. Then important rather topic about metering and billing, right? So if you use serverless, how do you get billed for it? How does the metering works? And then Simon will come back and talk about some of the top use cases and help you identify the adoption opportunities here. Again, we'll have some time at the end of the presentation for a Q&A. We might not be in a position to take questions, but if you do have a questions, please post it on the chat. We do have a few moderators, so they'll be happy to respond to you. And we will take some time at the end of the presentation as well. All right. So as a quick primer, right, if you're new to Aurora, Aurora is a part of an RDS service, and it provides you with a MySQL and Postgres compatible relational database built for the cloud. And it provides you the performance and availability of the commercial database at the fraction of the cost. So it provides you the performance scalability. It's the design itself provides you with the high availability and durability, highly secured, and more importantly, it's a fully managed service. So that's Amazon Aurora for you. And now we'll look at what serverless fits in within that realm. So before I go there, let me just quickly talk about the architecture of Aurora. So as you can see here in the Aurora architecture, the very key principle is the compute and storage are decoupled. So we call it, it's a decoupled architecture. So on the bottom half, if you see, there's a storage, which is a purpose-built log-based storage, and it's a distributed storage, and it spans across three availability zones. So anytime you're writing your data gets stored in all three availability zones. So we have 6 copies, 2 in each availability zones, and that makes Aurora highly available, durable system. And because we have hundreds of thousands of these storage nodes, your data is scattered amongst many, many storage nodes, and that's how we get the performance out of it. But the important part is that your compute and storage scales independently, right? So today in Aurora, I like to call it the storage is serverless. So when you provision Aurora database, you never have to provide how much size do you need or what are your IO requirement. It's all uh, as based on your usage. So as your data grows, your storage will grow. So we use something called as a protection group of 10 gig, and we'll keep adding those chunks for you based on your requirement. As your data grows, we'll grow the storage for you. So when you're provisioning your database, one thing is taken care of you is to figure out how much storage you need. Now let's look at the top part, the compute part. So in a provision Aurora today, you have to assign or you have to we have to pick a right instance size. So in Aurora, you can have a one writer and up to 15 reader. And those are your instances, those are your provision instances, which you attach to the Aurora storage. And this is what we call it provision. You pick your instance size, and based on your requirement, you might have to either scale down if you have to change the instance type or change instance type to a higher instance type if your workload demands. And Aurora Serverless v2 really fits in this architecture, and I'll talk about that in next year. So with the Aurora Serverless v2, when we say Aurora Serverless v2, we really focus on the compute side of things. As I mentioned, the storage side is really, it's always been a serverless, meaning that you don't have to provide any information. It grows and shrink on its own. Now we're taking it up to notch by changing or by providing you the compute with a dynamic capacity. So really what I like to think about serverless v2 is just another instance type, right? So you have many instance types available in Aurora. You can use DB-T4, R5, you'll use R6G, X2G. So you can attach these instances to Aurora storage and or run your workload. But with serverless, really what you get is a on-demand scaling capacity model here. So when you choose a type DB serverless, or in other words, serverless v2, we will grow and shrink your instance resources dynamically without interrupting your user connections, right? So you're connecting, you're running your business, you're running your applications, you're running your queries. But as soon as we see that demand for more capacity in terms of we look at CPU, memory, and network, and we'll grow and shrink, right? And really, it's a low-level resources. So it's not just your front-end application load. If there is an internal capacity that is required, the serverless will provide you with the right capacity in terms of CPU, memory, and the network, right? So what you're getting with serverless v2 is you have the Aurora storage, but now the compute part is also turning into a serverless where you don't have to make a decision of what's the instance size do I need to choose. That is taken away from you. So think of it as a box and it grows and shrink within that box. So more on that, I will pass on to Simon to talk about how does really the scaling works and what I need to look out for. All right, so over to you, Simon.
Thanks, Jag. So let's talk about scaling and capacity in serverless v2 because this is one of the crucial elements to understand, both to understand the unique capabilities of serverless v2, and it's also a very important ingredient in choosing the workloads that will benefit most from adopting serverless v2. So let's take a look at the main points for the scaling behavior. Can we go to the next slide, please? All right. As Chirag mentioned, the way of thinking about serverless v2 is that it's essentially another instance type where you do not have to specify or commit to a particular memory or compute capacity up front, but serverless v2 instances can grow or shrink dynamically. And the way the shrinking and growing works is that the resources and the demand for resources, such as CPU, memory capacity, and network capacity, are monitored transparently by the system, and the system responds automatically and transparently to the resource demand. As the workload goes up and down, the system will automatically scale up and down without you having to specify any thresholds or any logic for when the scaling should occur. So in contrast with some of the existing and other autoscaling features, such as Aurora read replica autoscaling, you don't actually have to specify any logic or thresholds for monitoring usage metrics or resource utilization metrics. Serverless v2 does that all on its own to sort of meet the capacity that is optimal for the workload that is currently on the database. And it's important to note that resource demand is not just the workload, it's not just the queries that the database clients are running. On a database, it could be a number of other things, such as internal maintenance operations, such as redo garbage collection, other things like that. It could be additional features that are enabled on the server that consume CPU or memory. The point is the monitoring automatically accounts for any sources of resource utilization and adjusts capacity to meet that. And so the model works such that the scale up on the resource scales basically instantly. As soon as the workload arrives and there's an increase in resource demand, serverless v2 will nearly instantly start spinning up capacity And that is transparent to the existing database connections that you have on your instances. So we don't interrupt existing connections. We don't have to restart the resource. We don't have to close existing transactions. Everyone who's already on the database can continue working with it, and the capacity is being provisioned behind the scenes. So that gives you a really good experience in terms of the seamlessness of scaling, because again, there's no interruption to existing workloads, and there's basically no way that existing connections would be affected, such as restarts of the database. So for scale up, we have that near instant behavior there, which we'll also go through on the next slide on examples. But one point is also important to note that for the scale down portion, we understand that database performance is one of the critical ingredients of the user experience. So the way scale down is designed is that we want to preserve performance as much as possible, but without losing the flexibility and the dynamic nature of scaling. So what scale down does is it is slightly delayed compared to when the workload actually subsides. And that's because database performance is basically all about memory capacity and having data warm in memory so that when queries arrive, you would have to, you don't have to read everything from disk. That is one of the key points in accelerating database performance. And the serverless v2 design accounts for that as well. So the scale down is designed to, not scale down in the instant of a second when the queries stop, because it is anticipated that the workload might continue for a little while. And so we'll see that example in a minute where the scale up, which is really important to ramp up as quickly as possible, is near instant, but the scale down is designed also to preserve performance. So we're talking a lot about the capacity that it grows and shrinks dynamically. So what is serverless capacity? So when discussing capacity, we are operating using the term of the Aurora Capacity Unit, or ACU. And one Aurora Capacity Unit, or one ACU, is the equivalent of roughly 2 gigabytes of memory, plus the associated CPU and network capacity. But roughly, we're operating with the terminology of memory equivalence when discussing Aurora Capacity Units. And so as of today, the supported range of capacity that you can define for your serverless v2 resource is from 1/2 ACU, which is roughly equivalent to, in memory terms, to a DB micro instance, to 128 ACUs, which is roughly in memory terms equivalent to a DB 8x large instance. And you can define the minimum and maximum ACU setting at the cluster level for your Aurora cluster. And that setting takes effect for every instance in the cluster that uses the serverless v2 model. And so the minimum and maximum configuration is a way for you to influence what are the boundaries for serverless v2 to scale down and scale up. So you can do it for performance improvement reasons. So set a higher minimum so that the bottom line for scaling point is higher and you don't need as much time to scale up. You have more upfront capacity if you want that. And maximum ACU is a good way to limit your cost on the other end of the spectrum. So you want to make sure that there is never consumption of ACUs higher than the certain set limit. So that is the basics of scaling, and we'll also go through some use case examples and actual examples how this is being assessed when you're looking at a workload opportunity. But now let's take a look really quick at an example, a very sort of zoomed in example of how a scaling action works. And again, this is a very sort of macro view of a single instance of the serverless v2 responding to a workload and then scaling back down. In a real scenario, you would have those events happening potentially, dozens or even hundreds of times per day as the workload requires. In this case, we have the serverless database capacity metric, which is available for your serverless v2 resources. And as soon as the workload starts, serverless v2 starts picking up capacity. You can see it's effectively an instant jump in capacity. And as long as the workload keeps going, capacity is continually being adjusted to meet the demand. And around 3 minutes after the workload started, we really don't see any scaling action happening anymore. And that's because the workload is no longer increasing and we don't actually need more capacity. And following that, with the workload actually subsiding, we see serverless scaling down in a couple of steps down to effectively here a half ACU, which was the minimum configured amount. So you see that we are going to be a little more conservative with scaling down just to make sure that this performance doesn't suffer should there be another query as part of that workload spike. Again, main points, near instant kick in scale up, which should be much, much faster than anything you can do today with something like a metric driven, lambda driven self-scaling. So this is going to be much more responsive and seamless at the same time. So now that we've discussed capacity, real brief, let's go and the billing and metering for serverless V2 as the next really key important point. So over to you, Chirag.
Okay, thanks. So yes, you heard great thing about V2, but now comes the important question, right? How does the billing works? How do you figure out how much ACU you're consuming? And so you can kind of predict what would be the cost of the serverless V2 would be. So to explain that, I have a couple of examples and I'm showing you some CLI command to figure out ACUs. So we'll go and talk about that. So as far as the billing goes, right? Remember the first slide I showed you, it's a decoupled architecture. There's an Aurora storage and the compute part, right? So anything on this storage side of things, nothing changed from the serverless. Again, we're going back to the point that it is just another instance type. So what is changing from the billing perspective here using Aurora Provision today, moving to Aurora Serverless, is the price you pay for your provision instance. So in serverless V2, you'll be paying instance cost rather than having a prefix cost or a provision instance that you pay by month. You'll be paying by ACU per hour. That will be your instance cost. The rest of the cost, the actual Aurora storage cost, any IO, snapshot cost, data transfer cost, they all remain same and actually will be the exact same as you would do in provision. Just like if you were to change your instance type, your storage cost might not change, your IO might not change. Well, IO might change a tiny bit because you're changing the instance type and your caching will change, but relatively small. And then you have a snapshot and data transfer cost remains the same. So looking at this example, you know, again, the rate for the ACU per hour differs between depending on the region you're operating. I'm taking an example of North America where it's 12 cents and in APAC it's 22 cents per hour. So the basic math is going to be if you're using 100 ACU per hour and then you're using it for a month, which is 730 hours in a month, and at 12 cents, it comes out to be about $8,700 and change. So that's how the billing works from the compute perspective. Like I said, the rest of the cost will still remains the same. Now, ACU per hour, yes, I told you, okay, I gave you an example of 100 ACU. But how do you find out how many ACU you're using, right? And let's look at a couple of examples to figure out, how does this ACU per hour works out here. So I'm looking at just an example here. Let's say you're running R6G2X large, right? It's a provision instance. And I'm trying to give you a comparison here, and then we'll go with some example here. So example here, R6G2X large, which costs about $4.15 hourly instance cost, and you're using 24 hours. So your monthly cost will be about $100. Great. You know that it's fixed. It's $100 per day cost for running R4 8X large, for example here. Now, the way I like to think it is, all right, if I have a DB serverless or the V2, which costs 12 cents again in certain region, North America for sure, in US East 1 and 2 and other US regions. It's going to be, if you were to do $99, if you convert that into an ACU per day, you're using about 830 ACU per day. So if your workload, you're using more than 832, then you are paying more than R62X large, and that might not be effective to you, right? So this gives you a little comparison on, okay, for a given instance type, how much ACU per day you can get. Now, important part, and I think I want to highlight here is one of the key benefit of using serverless V2 is we see customer right now here. I'm taking an example of R62X large. It might be over provision. You might not be using that instance 100% of its capacity. There are times in a day where you need this capacity, and that's the reason why you have that instance. Serverless V2 takes that equation out, right? It'll just give you the performance you need while you need that peak capacity, and then it scales down. So we know, okay, 830 ACU per day. And now my recommendation always is to run sort of a POC, right? So I have a couple of examples and let's run through it and understand how this ACU per hour works. All right, so moving on here, I have a first test that I did where my server is mostly bored most of the day. If you look at it at about 1700 hours, there was a flurry of activity happened, and that's about it. And this is one on purpose. I just did a work just for that hour. And by just looking at it, I can say, yes, it's hovering around 20. And actually, I should just mention here, if you want to find out your ACU per hour, we have a CloudWatch metrics. And the CloudWatch metric is called serverless capacity. And I'll come to that in a second here. But that's the metric that I'm plotting. It's what's the ACU per hour I'm using. So here you can say visually it's around 20, and then the rest of the day it's the minimum ACU, which is the half ACU. So that's what I'll be paying for this day. And for that, what I did is on the bottom of the screen, I have my cost explorer, which is giving me the total cost. And as you can see here, total cost is $2.97. It's telling me the total usage is 2471 ACU per hour, roughly equates to exactly what you saw in the previous diagram. But if you really want to do this thing per hourly basis, you can use CLIs. So this is the metric that I was talking about. We have a serverless database capacity as a CloudWatch metric. And really what I'm doing is that, hey, for a given day, start time and end time, for a certain region and give me a data every hour. And then I'm just running some awk foo here and just adding all the values that I get. And what I get is 2472, and that's exactly what you're going to see in the bill the next day. So if you're doing some tests, let's say for 3 hours, and you're going to find out, okay, what's my ACU per hour? You can use this technique and figure out what the cost or what the ACU would be, right? Let's look at the other example, right? This is a rather busier server. There's some spike happening, many more spike in the beginning of the day, and then I got some steady spikes happening. By looking at it, I would not know what the ACU per hour is. Yes, there's a bunch of spikes here. But again, I use the same technique of using CLI or looking at my billing console the next day. And here's what I get, right? Doing the same thing here. I did the checking the serverless database capacity. That's the CloudWatch metric. I do for a day. I add it, I get 135. My billing statement shows 135. So the point I'm trying to drive here is if you were trying to find out the cost to run the serverless V2, you can do this thing on a more granular way, right? Most workload that I see is that they have some batch workload happening in the morning, and then the rest of the day is pretty light. So while you do these POCs, you can then see if serverless V2 is going to be effective or not from the price and the performance perspective. The other thing I want to mention here that, and I think I'm going to cover a little bit more, is serverless V2, again, being the instance type, you can always mix and match. If you have a provision today, you can add another serverless. You can promote serverless to become a writer, run it for a few days, and then see if that works for you. If it doesn't work back, you can always switch back to provision. Or if you have a brand new workload and you're not sure what instance type you need, the other way to think about it is that you could start with serverless, figure out your pattern, figure out your number of ACU per hour, and then see if it's somewhat steadier, then you might want to go back to provision, right? So we will talk more on that. So again, now that you understand the billing part, I will pass on back to Simon to talk more about what are the strategies you want to look into in order to adopt serverless V2 and more effectively. So over to you, Simon, again.
All right. Let's take a look at how we evaluate good use cases and opportunities for serverless V2, and how can you actually reason or think about workloads and the metrics that you currently have or could produce about your workloads that would tell you whether that's a great candidate for serverless V2. Um, first, let's just right off the bat review the standard classic use cases that are usually great candidates for V2 evaluation. And just because of how the scaling behavior works, it wouldn't be a surprise that variable workloads are generally the best fit for serverless V2. And that is where seamless capacity management is really a value on its own. So yes, you can always scale resources using APIs. You can scale instances to larger type. You can use Aurora replica autoscaling to launch additional instances in the existing cluster. But all those techniques currently have a certain amount of delay, whether you're waiting for a new instance to be provisioned, or they have a certain amount of disruption to the existing workload. So scaling an instance in place, of course, is going to cause your database to restart. It's going to be between seconds and minutes of downtime, depending on what the application actually does when it sees a new instance, whether it reconnects immediately, whether it picks up the new DNS endpoint, and whatnot. But with serverless, all those worries are generally gone because, again, scaling is in place seamless. And there are very interesting use cases that actually go along with it. So, for example, you could put several serverless V2 instances behind an RDS proxy and let them scale transparently to give you a horizontal scaling solution where your replicas are using serverless V2, but the primary writer instance is not, because we do support hybrid deployments where only some of the instances are serverless. So there's some really interesting use cases behind that. We can talk about that later in Q&A. There have been some questions on that topic, so we'll go back to it. To continue with the best fit use cases, another good example is databases that are job or event driven, where the events or jobs are infrequent, but also not predictable enough that you could manually provision or scale resources for those events. So if you have an ETL database that's getting jobs from external customers, you can't quite predict when those jobs will arrive. Or if you have events that are coming from external systems and they do need the database to be available immediately, but there is plenty of inactivity in between. This is a great example of when serverless could just provide that near instant scaling without you having to even know when the events might happen. Development environments. If you have developers running tests, running deployments, building their apps, only maybe a few hours per day, only a few days a week. If there's too many of them, the management burden and sort of chasing after every owner of every database might be infeasible. In that case, instead of over provisioning for everybody, you can use serverless V2 for those resources, and it will basically scale itself down as low as the minimum ACU is configured or the workload requires. And you don't have to worry about scaling those environments anymore. Another good example is multi-tenant environments where there's a requirement for accounting or isolation of load between tenants. So if you have a lot of tenants on a single Aurora cluster, so let's say a whole bunch of schemas or databases with a single cluster, each belongs to a different tenant, it might become hard to see who is using how many resources. It might be difficult to isolate impact from one tenant being extremely active from another tenant that's suffering performance degradation because of that. And in serverless, you could potentially split those multi-tenant environments into separate pods where either individual tenants or groups of tenants get their own serverless V2 resource, which will scale automatically according to demand, but then each tenant is isolated. And as a bonus, you get capacity measurements or resource utilization measurements separately for those pods. There are some other cases where serverless V2 might not be an immediate hit, but there's still some possibility to evaluate if there's benefits to be had. And those examples are generally when you don't need scaling to begin with. The unique capability and value of serverless V2 is really the transparent, seamless scaling. So if you have a steady and predictable workload, you're not really scaling much. And in that case, you're not taking the advantage of the biggest unique capability with serverless. So potentially not a very good fit. Other example is workloads that are exceeding the current supported maximum capacity. Although there's a caveat here because especially for job or event-driven databases, you might sometimes be okay with those jobs perhaps taking slightly longer, But in exchange, you don't have to scale or over provision for those jobs. So it's not a clear-cut situation that serverless is not a good fit. It is still potentially a valuable solution there, but you would need some additional evaluation. We'll talk about how to evaluate that in a second. And again, lastly, as any scaling solution that responds to a workload, it is a reactive scaling solution in nature. So if there are use cases, although should be rare, where you require the database to provide maximum optimal capacity with no delay whatsoever, so the database to always sit warm, ready to handle workload at maximum performance, then the reactive scaling of a solution just such as serverless v2 might be something where the workload might need to tolerate a very brief ramp-up time. So that's another consideration to take into account. So let's take a look at how we actually identify opportunities. What kind of data, what kind of information we look at to see whether this is something you should take into account. So there are basically three steps in the equation here. First of all, it is extremely important to really understand workload requirements. Might sound trivial, but there are certain important factors where you need to look at your existing setup, your existing topology of database resources, and see whether you actually need and have the prerequisites and requirements for serverless to be a great fit. There are some basic prerequisites, such as the minimum engine versions that you have to be on in order for serverless v2 to be an option. So that is Aurora MySQL 3 or 8.0 compatible and Aurora Postgres 13 and up. So you need to be at least on those versions for serverless v2 to be available. And then there's workload characteristics. What is the scaling frequency and magnitude of your workload? So again, if it's a steady workload, there is really no need for scaling. There is really no major difference between the baseline or the low point and the high point in the workload. That's a different situation from when you have long periods of nothing with spikes in between. And that's a big magnitude of scaling, and frequency of scaling also affects how long are the idle periods between spikes. The longer those periods are, the more value serverless v2 can potentially provide by scaling down during those periods. Then scaling speed and workload impact. What is really the requirement from the workload perspective as far as how much impact can we take when we scale? So again, using a self-managed scaling solution, you could still scale instances and launch additional instances, put them under a custom endpoint, and achieve scaling using those techniques. But then you'll see workload impact that might not be tolerable in every situation. So if that is the requirement, if those are important factors for you, then again, there are unique capabilities in serverless v2 that eliminate those impacts. And then lastly, it is really all, at the end of the day, about the scaling convenience versus cost. Serverless v2 is a extremely convenient scaling solution because, again, you don't have to define scaling rules. You don't have to define thresholds for CPU, memory, and whatever else. It essentially works out of the box between the minimum and maximum capacity ranges that you specify. And that can be a value on its own. Like there could be a very substantial cost if you're managing those things by hand or if you have to over provision. So that is a critical factor here. If you would rather take some workload impact, or if you'd rather manage everything by hand using APIs and you're not worried about the impact to the workload, that's a consideration. If you want to offload all of that to a managed service, that is where serverless v2 is potentially something you need to consider. And then once you have the understanding of what is the scaling characteristics that you require, what is the impact that you can accept in your workload, what is your preference or the balance that you want to hit between convenience versus cost, you look at the options that are available in Aurora today. And like I said, there are multiple options. Serverless v2 is not the only one. You can scale manually. You can use auto scaling for replicas, for horizontal read scaling. And then looking at those options that we have today, really the last step is to review what is unique in serverless v2 about the requirements that lets serverless v2 meet those requirements better than any of the other scaling options that we have. And again, here we have near instant seamless scaling. We have really simplified configuration because, again, no thresholds, no logic to define. We have, and this is a very big point, very good feature compatibility with your existing Aurora deployment. So the features in Aurora that you are already used to are going to be supported with serverless v2, essentially out of the box. So this is different from prior serverless offerings, such as the serverless v1, where there were, in fact, fairly significant restrictions on features that you could use with it. With serverless v2, we are bringing that feature compatibility up a few notches, so you don't actually have to compromise or sacrifice the features that you like in Aurora today to use serverless v2. One of the very, very interesting capabilities that I love about serverless is the support for hybrid configurations. So again, because we are trying to think about this, just to simplify the thought model as an instance type, you can have a single Aurora cluster where some instances are still provisioned instances, but some instances are serverless. You don't have to commit the entire cluster to a provisioned or serverless layout. You could pick some of the readers if you want to try it first. You could pick all of your readers to be serverless and leave the provisioned instance on the primary instance. You could have any combination of that, and that actually not only gives you the flexibility in terms of serverless in general, what it does, but also flexibility in the context of your workload. If you have components of a workload hitting the same cluster that needs serverless scaling, launch a few serverless readers, put them under a custom endpoint, leave the rest on provision. So you have really great flexibility there to meet what the workload requires. And the last 2 points, which are also very, very important and great from the perspective of how easy it is to evaluate, is that because, again, you can convert instances in place into a serverless scaling model, and it's done on the same cluster that you already have, there's no need to technically perform any migrations. Usually when there's new products, new major features, there is an effort involved in adopting, evaluating by way of moving data to a new database or a new product. In this case, you're effectively just changing an instance type, and there is no migration, no commitment, because you can always come back. So you can do a very low risk evaluation very quickly. That is something where you don't actually have to necessarily do as much preparation, as much calculations ahead of time, because you can try it quickly. You can always come back, look through the numbers. Just like Chirag mentioned, there's metrics on the CPU and ACU utilization metrics. So you can try it for a bit. You can go through the metrics. You can come back. You can adjust your approach. You can always dial it right in. And there's no such commitment as I go to serverless and that's it, and I can never do anything else. So this is sort of the 3 major steps for evaluating opportunities. And I think it would be helpful if we also went through a couple of examples, because there is, obviously we kind of need to get to, like, how do you actually look at utilization metrics? What is it that you're looking for when assessing an existing database solution? And so let's look at 3 examples here. We have one example where I just pulled a CPU utilization metric from a database that is currently running on R5 8x large instance type, so 256 gigabytes of RAM, which is at the higher end of what serverless v2 supports, because again, serverless up to 128 SUs, which is equivalent to 256 gigabytes of RAM. And so in this solution, we have a pattern of utilization on a database that is fairly spiky. There appear to be not only just transient spikes, but also perhaps a few longer periods of usage. But those spikes sometimes are flat, so it looks like some kind of event or job-oriented database. Important point is we're never really going above 65% CPU utilization, so we are definitely well within sort of the range of capacity that serverless v2 supports. So that's great. That's one checkbox. And then the critical part is we have so much nothing in between those spikes. There's so many periods of inactivities that it almost looks like the database is only used for maybe 4 to 6 hours per day, and it's sitting there doing absolutely nothing in between. So that is the kind of thing you're looking for when you're evaluating or looking at metrics and utilization metrics from your existing databases. This would potentially be a great candidate to evaluate for serverless V2 because we have the two critical parts. We have a workload that needs scaling. There's very spiky workload, and we have a workload that has a long period of inactivity in between those spikes. So there will be plenty of opportunity for serverless to scale down and save you money. So let's go to use case example 2, which is slightly more complicated. So right now we're looking at a R5 12x large, 384 gigabytes of RAM. So that is actually beyond the current supported ACU range in serverless V2. And not only that, we are also hitting nearly 100% CPU utilization during the spikes. So you still have spikes. We still have longer periods of inactivity in between them. So that looks like potentially a fit, but what do we do about the capacity? It's outside of the range. So is this a good fit or is it not a good fit? And it's an open question. That's why I think what Chirag mentioned is a proof of concept project and evaluation is really critical to do here because, hey, maybe those jobs are not operational workload. Maybe they're some kind of ETL jobs. Maybe it's fine if they take 20-30% longer in exchange for not having to run a 12x large instance 24/7, instead scaling down in between those periods. So even in situations like this, where in theory you're sort of outside the parameters of serverless V2, you can still evaluate and potentially have pretty substantial benefits from those several hours of complete idleness. Lastly, let's take a use case example 3. And in that case, we are well within serverless range. So this is a fairly small instance today, 2x large, 64 gigabytes of RAM, and our CPU utilization looks a little less spiky. It's in fact just oscillating between 20 and 50% CPU. So there isn't really much to it in terms of the need for instance scaling. It is fluctuating, but it does appear to follow a sort of a sinusoidal pattern throughout the day. And it's basically below 50% CPU all the time. In this particular case, this is an example where you don't appear to need scaling to begin with. So probably not a top pick for a serverless evaluation. And in that case, you might as well be able to scale the instance down within a provisioned model, maybe put a reserved instance on top of that to save additional money, and that could be your solution. But in this case, you probably wouldn't need seamless scaling as much as for serverless V2 to really shine in this example. You could still try it and see whether the average wouldn't come below your current. But in real life, I think this would be a better candidate to stay on provisioned, perhaps with reserved instances on top to save cost. So that concludes our examples. And really wrapping up all that we've discussed so far before we go into Q&A, thanks to the easiness, and the low risk with which you can evaluate serverless for your workloads, we really have a simple as 1 to 3 steps for serverless V2 adoption and evaluation. As discussed, certain characteristics with serverless would help you identify the matching workloads that you have that meet those characteristics. You can evaluate very quickly and easily because, again, just an instance type effectively, no commitment, no migration necessary. And then whatever your success indicators are, whether that's scaling, seamlessness, or cost, thanks to the metrics that Chirag demonstrated, you can get those confirmations on your key success indicators really easy as well. So that's it for the presentation. Thank you so much for listening. We do have a number of interesting questions, I think, to cover from the chat. So we'll do that now. Chirag, would you like to take a first one? And we'll try to pick questions that did appear multiple times first, if possible, but we'll just go through the ones we saw on chat as we were presenting.
Sorry, I was talking on mute. So yes, let me take this question. So the question is, when the instance is scaling, how do we change the parameters, right? Especially shared buffers, and there's a whole host of other parameters that needs to be changed. Well, it is a dynamic in nature. I think Steve already responded, but let me just add a little more color to it, right? So let's say your max ACU is 64. So when that happens, any other metric that we have or the parameter that we have will make that based on that settings, right? And more importantly, the shared buffer is actually a an important metric, and we have done a lot of work around it where we can dynamically allocate more buffers and evict buffer when we scale down, right? So you don't have to worry about the shared buffer part. Part of the scaling, because we are giving you the memory, part of the giving memory, if there is a pressure on the shared buffer, we will add more pages. And as we scale down, we can take the pages down, right? The other thing to remember, I'll speak more on Postgres side of things, but it's really applied to both engines for MySQL and Postgres. For example, let's say you have, I don't know, making up a parameter here, let's say a number of vacuum worker, for example, right? Again, those numbers, what we'll do is it'll be based on your max ACU, right? So max ACU is 64. Based on that, we'll have some numbers. So as you scale up, or if there is a requirement for vacuuming, well, we will be able to give you that many number of workers because that's the max ceiling that you have of 64. Right? So again, the point I'm trying to drive is that all of these metrics are based on your max ACU settings, and you don't have to really restart on that part. Do you want to take the next question here?
Sure. I'll try to pick one that talks more about the architecture and how you can mix and match instances because I think it's a really important point there. And there was a question on clusters that have instances, multiple reader nodes, and custom endpoints. Um, Effectively, again, we are you could mentally treat serverless v2 as an instance type, so there shouldn't be any impact to your existing topology. You can have the readers, either all of them or just some of them, using serverless v2 model, and still the way they are included in custom endpoints wouldn't change. It's effectively not going to be any different. So again, you can mix and match instance types, and it doesn't have to be all readers are serverless. It could be one instance, could be some of them, could be all of them if that's what you want. Um, so there should be no difference effectively for you in that scenario.
Right, so I'll take another one. Will Aurora Serverless V2 will have data API like V1? Yes, currently V2 does not support data API, and that's something we're looking into it. Will it have it anytime soon? I'm not sure, but that's something we are looking to bring the parity. Um, I think there was a question around from Aline, the Aurora Postgres cluster with a writer and a three reader, and we have a custom endpoint for two readers. How can we use serverless with the custom endpoint? Same thing. Again, we keep repeating this. It's another instance type. So if you created a custom endpoint for provision, you could do the exact same thing for serverless as well. Let's see. While I read through, Simon, do you want to pick anyone?
Sure. I think there's a good question about what to pick for serverless capacity when you're actually running global databases with primary and secondary regions for disaster recovery. And this is a very interesting use case, in fact, because you have so many models to consider when doing disaster recovery, whether you provision the secondary resources to be always ready and at the same sort of size as your primary resources, or you use something like pilot light architecture where there's only a minimum presence in the secondary region and then you scale from there. And so when you're talking about a global database deployment with a primary and potentially multiple secondary regions in Aurora, serverless V2 is a fairly interesting option because it lets you scale down automatically in the secondary regions when there's no workload, because this is only a passive region with no workload actively ongoing. But as soon as you actually promote secondary region to be a primary, then serverless will start scaling instantly to the capacity that is required to handle the workload without you having actually to do anything, as in preparing that secondary region to take the workload. So it could be a very interesting option to actually use a fairly minimal ACU setting in secondary regions. The original question is what minimum ACU to use. It would be, the answer would be as low as to be cost effective and as high as to be able to pick up the workload within the time that you want once you fail over to the secondary region. But what serverless V2 allows you to do in this case is not have to have another step in the workflow. Hey, I need to fail over, and then now I need to wait 10 minutes for instances to scale up in the secondary region, and then only I can fail over. With serverless V2, you fail over, it starts picking up workload instantly, it starts scaling instantly, and it reaches optimal capacity, on its own. So another example of an interesting use case there. I think there is also a question for when we saw cases where serverless was not a good fit. And I think it goes back to my third
Okay.
example. I've seen this more than a couple of times where the workload was essentially flat as a table. There was no fluctuation to the workload. Um, there was no need to scale the workload. It was perfectly possible to fit the workload on a provisioned instance, and there would be no more than 10 or 20% of deviation from baseline CPU utilization. In those cases, if you don't need scaling, then you probably don't need serverless V2 unless you have other requirements such as usage accounting, multi-tenant workload isolation, or those cases where it doesn't matter if scaling is needed, you also need the convenience factors of those other serverless V2 features. So I wouldn't say that it's a case where it's just never going to work. It's just the case that is less obvious and perhaps needs a second look.
Yeah, and the other one that I've seen is, if you don't set your min and max, that was with a customer where their max was 128 and the min was like 100. So the min was really, really high. And that tells me that, they need that capacity all the time. In that case, definitely the provision was definitely more cost effective, right? Uh, they needed uh, that minimum capacity that explains that it's not a steady workload there. Um, I'm seeing a bunch of questions around the use case. I think we talked enough on that cases. Um, let's see if I'm missing anything. Steve, keep me honest here. Did we miss anything? I'm scrolling through it. All right. Please raise your hand if we missed your question. I know there's just a ton of discussion here. So, yes, the slides will be shared. Um, and Anish has a question. Anish, what questions of yours was not answered?
Yeah, so basically, during Aurora Serverless V1, right, we had this concern sometimes that it was not having enough inactivity to scale. So customers were having that issue where they were unable to scale the workload because there was activity going on the database. And in V2, is that improved? And do you still need to have an inactivity in the database to do scaling?
Down, you want to take it?
I think it really depends on how we define activity. That's the critical part. If activity is actual resource utilization, if we are using CPU, memory, network resources as part of activity, that's going to prevent scaling to a certain degree. And so sometimes in database workloads, there doesn't have to be active query execution in order for memory or other resources to be consumed. So for example, if you, it's a good example in MySQL world where you come into the database and start creating temporary tables in memory, but then you stop your session, there's nothing else happening. You're still consuming resources at that time. So that session will be a factor that affects how far down serverless V2 can scale. But just in terms of connections being there, not doing anything, not having any open resources, not actually utilizing anything like that, um, it is it is going to again depend on what the resource consumption is. Just the connection existing in the database wouldn't alone prevent it from scaling down.
Right, let's take an example, right? If you have select statement running on your database, you have maybe 10-20% of CPU, or it's going up to maybe 60-70% CPU that you need to have a scaling requirement. Would it be able to scale to meet that high requirement of CPU, lot of SQL statements running?
I'm not sure if I understand exactly, but
Yeah,
if you're asking whether it is able to scale up to that level, that is the designed use case. You have activity incoming, and we want to meet capacity. So if you remember one of the graphs that I actually showing how a single workload spike could look, the way I demonstrated this is basically taking an instance that is doing nothing at the moment and launching a bunch of select statements on that database to drive some CPU activity. And that instantly started scaling up. It eventually stopped scaling when it met the capacity that is needed. So it's not like it's going to go all the way up every time. It'll try to meet the right capacity level for the workload. So it could be, whatever, 10 ACUs, 20 ACUs, 50 ACUs, but it wouldn't go all the way up unless the queries are actually so heavy or there's too many of them that it would be required.
Okay, thank you. That helps.
I'll take one question. We have 1 minute, so I'll take the last question from posted. Can serverless improve HA? For example, if we have one node as a production node and one node as a DR, can we replace the second node with a serverless node and achieve the same level of availability? Well, the short answer is yes. You can replace your reader to serverless. So there are two modes to it, and actually it's interesting here. When you set your reader node, there is a priority that you can set. So if your reader's priority is set to 0 and 1, so you got to be careful about if you're cost conscious here. So for example, your writer is doing all the work and you mentioned your DR node is just sitting there for high availability perspective, right? If you set your serverless with the priority mode, the replica one, either 0 or 1, what that node is going to do is actually going to follow the ACU of the writer. So let's say a writer goes to, I don't know, 100 ACU because there's a lot of work happening. There's If the replica in that case, if the priority is set to 0 and 1, it will follow the ACUs of the writer. So you're paying for the ACU on the reader, even if you're not using it. And the reason why we have that is for high availability. So when you failover, let's say if the failover happens at that time, you have all the capacity of 100 ACU right off the bat. The other option is, yes, you can set it to a higher priority, higher than 2. Well, in that case, what's going to happen is it's going to stay at the minimum capacity in case you're not using that replica node. So again, going back to the example, if your writer is 100 ACU and your min ACU is, let's say, 16, your reader will stay at 16. But in that case, when the failover happens, if you need the 100 ACU capacity right at the time of the failover, you will not get it, right? So you will suffer some of the, well, you have to, it will scale up on the failover, but you'll have to wait for a certain time to get up to 100, right? So that's the difference. But to answer your question, yes, it is exactly the same. Again, the instance type, so will fail you over, and depending on your settings, you will have the ACU on. All right, I think we're at time. So again, I want to thank you everyone for your time. I hope this was useful. Again, if you can give us your feedback, that'll be very much appreciated. And I guess for the slides, we will share it once you register. It will come in your inbox. So thank you again.